this video, we're going to look at the first derivative test and how we use the first derivative test to find local extrema and determine if our function or where our function is increasing and decreasing. Just a couple of important things to note before we get into it. Your function's got to be continuous and it's got to be differentiable everywhere within the domain. As long as you have that, and you are good to go. First derivative test will work out. And then just 3 simple steps that we're going to follow in order to make this this test work. Number 1, you got to find those critical points. If you don't remember how to find the critical points, check out my video on finding critical points. Very simple and easy. Step 2, you're going to make a chart for increasing and decreasing. There's multiple different ways of how to do this out there. I try to keep it pretty easy and straightforward. So hopefully my way will make a lot of sense to you. And then number 3 is we're going to use that chart to determine our local min and max. So let's jump into it. So here we have f of x equals 4x cubed minus 3x squared. Since this is just a simple polynomial function, we know that it's going to be differentiable and continuous everywhere. So first thing that I want to do is I want to find my critical points. So we're going to find our critical points by taking the derivative of f, and we get 12x squared minus 6x. And then once we get to this point, we're going to take that derivative and we're going to set it equal to 0 and solve for x. And that's how we get our critical points. Let's factor out a 6x from both these. That gives us 2x minus 1 equals 0. And then we can break it up and say that 6x equals 0, 2x minus 1 equals 0, and solve. We get x equals 0, we get x equals positive 1/2. Now, these are our critical points. Once I have these two things, I can use my critical points to create my little positive and negative chart, okay? So the way that I do this is I just draw a simple number line right here. I'm going to put 0 here, and I'm going to put 1/2 right there. And then these critical points represent where something could happen with our function. And so what I want to do is I want to be able to test what the function is doing before and after every critical point. So in order to do that, what I'm going to do is I'm going to pick a number that falls in between that interval, this interval, and that interval. Make it easy on yourself. What's a number that's less than 0? I like -1. What's a number in between 0 and 1/2? Let's go with 1/4. And then what's a number greater than 1/2? Keep it easy. Go with 1. Once you have your 3 little testing points, what we're going to do is we're going to take each one of those testing points and we're going to plug it into our derivative, and that's going to serve as our derivative test. Okay? So when I take -1 and I plug that in to my function, to my derivative rather, we're going to get 12 plus 6. So f of -1 gives me 18. All right. So what that means, since we got a positive value out here, that means on this, within this interval from -infinity all the way to 0, our function is increasing. The positive number, the positive output here tells me that we're increasing. So now we're going to test our next test point, which is going to be 1/4. So we have 12 1/4 squared minus 6 times 1/4. Simplify this out. I'm going to get 12 times 1/16 minus 6 over 4. Continue simplifying. 12 over 16 minus, and I think since we need to get a common denominator here in order to subtract, I'm going to go ahead and multiply these two here to give me 16. And so I'm going to multiply the tops and bottom by 4. So that's going to give me 24 over 16. Simplify that out and we get -12 over 16. I'm not too concerned about simplifying that. I mean, you can if you want to, but get our prime symbols in there. I'm getting a little sloppy, I apologize. We know that f of 1/4 gives me a negative number, which is what I really care about here. Okay, so that tells me that within this middle interval here, we are decreasing. All right, so again, all I did so far was I found my two critical points, and then I just put them on that little chart, critical point, and I picked three values, three numbers that fell within the intervals before and after my critical points. And that's helping me figure out some cool stuff coming up. So we've checked -1 in our derivative. We've checked 1/4 in our derivative. So finally, let's check f prime of 1. So we have 12 times 1 squared minus 6 times 1. That's obviously going to give us 12 minus 6. So f prime of 1 gives us 6, which is a positive number. So that tells us quite a few things. It tells me this. It tells me that my function is increasing from -infinity to 0. We are decreasing from 0 to 1/2, and then we are increasing from 0 to positive infinity. So that's one thing that's really helpful. And then we can also look at this. I know in order to go from positive to negative, we have a maximum because we're going from increasing to decreasing. So right there at 0, we have a local max. And then we go from a decreasing interval to increasing, and that occurs at a minimum. So we have a local minimum at 1/2. So again, this is our first derivative test. Very simple. Find your critical points, and then using your critical points, set up a chart where you can test for positive and negative, for increasing and decreasing spots within your function, intervals within your function, and then we're just going to simplify it out. We're going to test those spots. That'll tell us what intervals our function is increasing, what interval our function is decreasing, and so forth. And it'll also allow us to find our local min and max. Thanks for checking out my video. I'll see y'all next time.